Welcome to Calculus by Ansari. What I want to do in this video is discuss what calculus actually is and sort of discuss the reason why we study calculus and who invented calculus and the applications of calculus before we move on to actually solving calculus questions and so forth. So first, let's search on Google and let's see what Google tells us the definition of calculus is. So let's see, what is calculus? We search that up and we get the definition, which is the branch of mathematics that deals with finding and properties of derivatives and integrals of functions by methods originally based on the summation of infinitesimal differences. The two main types are differential calculus and integral calculus. So what does this really mean? So let's start by going to Desmos, and I'm going to graph a simple function, and the function will be y is equal to x to the third. So you should be familiar with this if you are studying calculus at this point. And we're just going to study the positive values of this. So from 0 to infinity. So right there. So let's just say this graph that we have graphed is the position of some person running as a function of time. And what that means is the x-axis is time, and the y-axis is the position depending on the time. So at 1 second, the person is at 1, and you can think of that he or she starts from 0 and goes to 1, and after 1 second arrives at 1. After 2 seconds, well, it arrives at 8. After 3 seconds, it should be 27, right? So we got to go up. 3 seconds, 27, right? And again, this is the position of the person, because we're defining it to be the position of the person as a function of time. And what if we wanted to know the speed of the person given this only? So the only thing we have is the position of this person as a function of time, and we want to know what the speed or how fast he or she is running to get to that position at an instant in time. So let's say we at 1 second, exactly at 1 second, we want to know how fast the person is running. So if we wanted to do that, we can make some good estimations without calculus, right? We can essentially what we can do is we know that if we know the position of the person as a function of time, the slope should be the speed, right? Because the slope is rise over run. Rise is the position, x-axis is the time, position over time, change in position over change in time is speed. So we could take the slope and figure out the speed. But the weird thing about this is there's no slope, right? This is a curve. So how do we take the slope of this curve? And essentially that's where calculus comes in handy. What we do is we zoom, we zoom a lot. We with our mathematical abilities, we zoom a crazy amount, and essentially after we do that, this just ends up looking like a line. So if we keep zooming, notice that if we just take this part, it looks very similar to a line. So now it seems like we're dealing with a line just because of how much we've zoomed. And if we keep doing that, then there's no difference between a line and this curve. And so now we can simply calculate the slope at any given point, right? And we can figure out how fast a person is running. And essentially, this is what calculus gives us. The tools that we gain by understanding calculus, we can do things like this. And this right here is differential calculus. It is calculating the rates of change of things in order to solve for physical phenomena. Now, let's talk about the inventor of calculus. So if we search on Google, who invented calculus? Let's see. Usually we get Isaac Newton, but also there's a lot of arguments that Leibniz was the inventor of calculus as well. And I think a good way of looking at this is they were actually both the inventors. They were thinking about the same thing at the same time, essentially, and they were doing it for different reasons. So Leibniz, he just invented calculus purely. That means he wasn't doing it for a certain reason other than inventing a new way of mathematics to understand physical phenomena, but Newton was actually inventing calculus to help him understand physics, and especially gravity. As he was inventing the ideas of gravity and gravitational force, he came up with a new way of math, which was calculus, to understand physics essentially. So what we can say is they were both the inventors, and they both had thinking about the same idea with different notations. So they didn't have much contact, so they would have different notations for the same idea. For example, there's something called a derivative in calculus, and Leibniz notation is something like this, the rate of change, dy dx, and Newton's would be something like this. And now there are many other notations such as x dot and some other ones, but again, these are the same thing but different notations due to the different people that have invented. Now, let's discuss a little bit on why we learn calculus. Well, we do it because we have a desire to understand physical phenomena, and eventually we want to use this for our everyday job. And jobs that include calculus could be engineering, if you want to be a doctor, or even works like business. If you want to be a business major, you definitely use calculus. And an example of that is, let's say we have some sort of function that gives us revenue depending on how much we produce. Sorry, I'll call this P of X or actually R of X for revenue, depending on how much we produce. So let's say this has something like 3x squared plus 70, 4x minus, 950. So x is how much we produce of a certain good or service, and R of x, the output, gives us our revenue. So we can use this, we can actually do something called the derivative to figure out the optimal amount of production. And what that means is how much should we produce of a certain good or service to maximize our revenue. And it's usually the intuitive thing is, okay, well, if you produce more of something, then usually you're just gonna make more money, right? But that's not always the case. And calculus helps us solve for an optimal rate of production to maximize revenue, and we can do it very mathematically and precisely. So yeah, I just wanted to introduce calculus a little bit in this video, and then starting next video, we're going to start talking about the first thing in calculus, which is limits. So I look forward to seeing you guys in the next video.